So, hello everyone. Good afternoon. I am Baban, and today, we'll discuss some assignment questions for week 9. So, I'll just wait for 2 minutes before starting. Uh, okay, so let's get started. We have a first question is an MCQ. We have four options, and we have to choose which one of them is correct. So here only one option is correct. The question is that there is what is the what is the property of hidden Markov model? So hidden Markov model, there is a hidden Markov model, and what are the assumptions that we are making about this model? What is the Markov property? So the first option is that the future state is dependent upon the current state as well as the entire past sequence. So basically for I plus one step, it will depend upon I state as well as like all the I minus 1, I minus 2, every state. This is the first option. Second option is that future state only depends upon the current state, and it is not dependent upon whatever the previous step is. It is just dependent upon the current state only, and given the current state, it is not dependent upon the uh, past states. Third option is that future state depends upon the past states and future states given the current state. And the last option is that future state depends only on the past states, and it is not really dependent upon the current state. So which one of the four options is correct? You can write the answers in the comment box. Okay, so I got one answer, which is B. Anybody would like to answer it?
Sir, can you show the question, sir?
Sure.
Sir, B maybe. B is the answer.
Right. So yeah, so this is like a basic conceptual question here. So B is the correct answer. Basically, what happens in HMM is that we have it is it is assumed that if we are having the current state, then current state contains all the information that we need about the future states. So that is why we don't really need the previous steps. So that is the assumption in the hidden Markov model, and because of that, answer 2 is correct. Answer B. So then we'll discuss about if any nodes are correlated in graphs. So let's let's read about some rules. So at first is that if two nodes are connected, like if there is one node here and there is another node here and they are directly connected, then they are like not independent, they are correlated with each other no matter like what other node is given. If they are directly connected, then they are not independent. So this is one rule. Then x to z to y, so like 1, then like 3 nodes are there, suppose in first there is direction here and here also another direction. Okay, so x, the first one is x, second one is z, and third one is y. If this scenario comes, then we can say y is independent of x. So suppose let's consider here this to this, like we can say it is coming to from this to here and this to here. So if this happens, we can say y, which is the like we are considering last one, y is independent of x, y, so here E is independent of b only when given x, given z, so given c here. So basically what I am saying is that if it is coming like b to c to e, then these two are independent when c is known. Okay, so this is one rule. Similarly, there is another rule, just the opposite direction here. Suppose there are like there is arrow from there to there. Again, in the same case, if this is known, then these two are independent. So this is like these two rules. Okay. Another one is that if we have z as a parent and we have x as a child and y as a child. Okay. So this case, right? So if we have we have c as a parent and d and e as a child. So in that case also, if this is known, then these two are independent. Okay, and we have a final option left, which is z is a child of x and y. So similar to here, c is a child of a and b. So in this case, we can say that as x and y, so child's the parents are independent if z is not given. Okay, so if this is not given, then they are independent, but if if c is given, then they are actually dependent. Okay, so these are the rule for like unidirectional graph. Okay, so we have the based on the rules. Okay, we have the following question. We have a Bayesian network and we have two students, and one student is saying that a given b and d equal to a given d. Okay, so this is one student saying, and another student is saying is that a given b equal to p of a. Okay, so again here there are no condition in the like here p of a given nothing. So here like we are assuming that other variables are not known. Okay, so here it is saying is that p of a given b equal to p of a, considering that all the other variables are like unknown. Okay, so this is the second claim. So can you say which student is right? Maybe both of them are right, none of them are right. Which one is it? So okay, just student A's claim, is it true or false? Let's focus like one claim at a time. So student A is claiming that p of a given b and d equal to p of a given d. So is it correct? No answer. So what does a given b d equal to a given d means? It means that a and b, so here we have A given B D, and here we have only given A given D, right? So it means that A and B are independent given we have D, we know D. So A and B are independent given we know B. So given we know D. So is it correct?
It is correct, sir.
Why?
Because they all are going towards C, and C is going towards D. So it becomes the last case where C is the child, and this one will be the C's child. So it is the last that V structure what we get now. So it is similar to the V
So
structure.
here it is V structure, okay.
So they both are when C will be given, they will be inactive. They will be active,
They will be
so
active, yeah.
they will not be independent. So here D is given, so they will be independent.
So okay.
So it like
Go ahead.
okay, so this is the opposite case. So when D is given, they will be not independent. Yes, correct. Correct.
Yes.
Sorry.
So here like P of A given B and D. So basically what we are trying to see is that if A and B are independent, so what will happen is that, so we are saying that A is independent of B given D, but right now C is not blocked, okay. So we can have a undirected path from A to B. We can reach from A to B via this, right? So they are not really independent. So it is saying that A and B are independent, but that is not really the case, okay. So this is like not correct. Another claim is that P of A given B equal to P of A. So here we don't know C, we don't know D, we don't know any of those. Just P of A given B equal to P of A. Okay, that means like P is like A is independent of B. So is it correct? Given we don't know anything.
No, that is also false.
Not really. So here basically what is happening is that here because C is not given, okay, so in this case like they are kind of like dependent, sorry, yeah, they are independent because in the rule you can see that this is the rule, okay. X and Y are independent if Z is not given. So if C is not given, then it will be independent, okay. C is not given, then it is independent, okay. But why it is dependent here? Because D is given and D is the child of C. So basically what is happening here is that because D is dependent upon C, okay, so by that this way if in any of the C is blocking, then we can say that because of the block at D here, okay, and D is directly dependent upon C. That is why this node is like is not cancelling, okay. So in this case, in this rule, okay, X and Y are independent if Z is not given. So in this case A and B are independent if C is not given. Here although C is not given, we have D given, okay, and D is dependent upon C. So that is why it is not really like it is actually not really independent. So that is why this one is false, but this one is true, because like in this case C, D, E, none of them are like no. So that is why P of A given B equal to P of A, okay.
So the first point, the reaction that P of A given B D, that can you just explain once more how it is coming, that relation? That
Okay, so if you look through the rule here, okay, x to z and y to z. So basically, z
no, no, sir,
given.
I'm not. So sorry, I'm not asking that.
Yeah.
Can you go back, sir? This relation, no?
Mm-hmm.
P of A given B and D is equal to P of A given D. So how this is coming, like this relation, no? Uh, you told, no, means A and B will be. You explained something, no? It depends, like A. It will be like P of A given B and P of A given D. Will it be like that?
Mm, can you repeat once more?
Sir, P of A given B D, whether it will be equal to P of A given D and P of B given D when both are independent.
When both are independent, uh, no, no. So when both are independent, what we are saying is that uh, P of A given B and D. Okay. So if they are independent, no.
So it is like this, we can open it up, no? P of A given B
Mm,
into P of A given D. D for so here it is, he is asking like P of A given B is equal A given B and D is equal to P of A given D. So that I understood how it is calculated. But from here, because normally we'll get a statement. And now this time, first time we got this relation. So that relation to statement, that how you came, that only I was asking.
okay. From this
Uh,
relation to this statement, right?
yes, yes, yes.
Okay. So here we are saying is that A given B and D and A given D. So here we are considering that B is not required, right? So basically we are saying that A given B D equal to A given D. So basically we are implying that B is not required. Am I right in this equation?
Okay,
So B
okay,
is not required means what? Uh,
okay.
if we are trying to calculate A and we have the D, but we are saying that B is not required. When B will be not required? When it is independent, right? That is
So this relation for some other graph, if it is there, so but implies A is independent of B given D, will be valid for other graphs also, or
yeah,
whether this for
right.
the same
No, it is held for everything, every other.
another type of graph. It is not this statement, if it is written like this relation P of A given B and D is equal to P of A given D implies A is independent of B given D will always
Always
be
be valid,
valid.
right?
Okay, 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 sir. Okay, sir.
So this is the directed graph, but in the undirected graph, okay, what happens is that it is not like we don't have any rules like that. Whatever we have mentioned in undirected graph, what happens is that suppose C is known, so C will be blocked. D is known, D will be blocked. So no other relationship we need to find anything. Just whatever node is given, that is blocked, and then we have to find if there is a path. Okay. This is the rule for undirected graph. So here student A claims P of A given B equal to P of A. So A given B equal to P of A. So again it is claiming that like A and B are independent given we don't have anything this given. So is it correct? So the difference from the previous question is that here the graphs are undirected.
This is false.
Mm, okay,
C is not given, no, so
this is
it is
also
false.
yeah. So any other answer from the chat? No. Okay, okay. So here in the undirected graph, you need to check that you have to kind of remove all the nodes that are given and see if you can reach from the start to end. So here C is not removed, D is not removed, E is not removed because nothing is given, right? So A to B, can you reach? Yes. Via C you can reach from A to B, right? So they are connected, that is why they are not independent. Okay, so first statement is false because we can reach from A to B via C. Okay, then the another condition, A given B and C equal to P of A given C. So that means here it means that A and B are independent given C. So is it correct?
Yes, sir. No, it is blocking. No, C has blocked.
Yes. So in this case, suppose here we have given C. Okay, so C is suppose cancelled. So can you reach from A to B? Not really. Like even if we try to reach from via D, via E, whatever, we have to pass through C. Okay, so we cannot really reach from A to B without going through C. But if C is cancelled, then we cannot reach. So that is the answer here. So if we cannot reach, that means like A is independent of B. Okay, so let's go to another question. So this is again directed graph. Okay, so the first option is that D is independent of B when C is known. D is independent of B when C is known. So is it correct? Just let's go through like one option at a time.
Yes.
Why?
C, sir, actually C will be blocking. So
Okay.
D and B becomes independent.
Okay.
It is
Okay.
C is a causes D and B.
Right.
So C, when it is known, like it is blocking.
Yeah. So like other journalists are also like encouraged to participate in the discussion. Like you can unmute yourself and also you can write in the chat box. Okay. So here like C is given, so C is blocked and we cannot really reach from D to B. So we cannot really reach D to B. So that is why this is correct. Okay, they are independent. Then A is independent of C given E. So is it correct? So the one point to note here is that uh, E is directly E, D and E is directly connected, right? So if okay, so we know E here. So will that affect D, and will that affect the connection between them?
False.
Right. So even in this case, like what is the rule that if we are having this kind of scenario, that there are two parents and one child, and the nodes are edges are like that, so this they will be independent when D is given, but here D is not given, so that is why like they are not independent. Then A is independent of B. A is independent of B when E is known. So we know this and we are saying that this and these are independent. So is it correct? Okay, so answer here is false because suppose we have considered here in the previous example that A or C are not independent. Okay, and then we are having this situation here. Okay, B is dependent of C. Okay, so A or C are not even independent and B is also dependent on C. So A is also not independent because C is dependent on A and B is dependent upon C. So that is why like indirectly A is dependent of B because there are no like blocking of the paths. So this is also not correct. Last option, A and B are independent when C is not. So this path is blocked. So is it correct?
True, sir.
Yeah, it was the answer to the previous question, I guess, Deepak. So yeah, you are right. So yeah, in this case it is false because suppose in this case C is gone, so D and B are independent. Okay, and even though A is dependent upon D, there is a like a breakage of path here. D to B we cannot go. We cannot go if C is known. So A to B also we cannot go if C is known. So this is also true. Okay. Okay. Then let me move on to the next question. Yeah, this is again this one is undirected graph. Okay, so we have to find out which of the given options are independent. So C and D are they independent? D and E are they independent? E and C are they independent? Given B, like in all the cases B is given. Okay. So C and D are they independent? Given B,
Yes, sir.
right? Because C to D is going via B, but if B itself is given, then suppose this node doesn't exist, then we cannot go C to D. So it is right that C and D are independent given B. What about D and E? D and E given B, are they independent?
No.
Yeah. Because why? Can you discuss?
So they have a path D to E.
Right. So D to E is directly connected, and if they are directly connected, no matter what nodes are like visible or not, they are like not independent. Okay. Then E to C, E to C are E here and C here. So and we have B given. So are they independent?
Yes.
Yeah, because like B is blocking, so E to C we cannot reach. So that is why this is also independent. And final option is that A to F, A to F, and we have B given. So can is it are they independent?
No, sir.
Mhm.
Yeah, they are not independent because we can reach from A to C, A to F via C. B is blocked, but C is not blocked, right? So we can reach from here to here. So the options are C, D, and AF, I guess. Yeah. C, D, and AF are the correct options. Okay. Then we'll go through another example here. Okay. Then we'll go through some numericals. Okay. So again we have the undirected graph here, and we have to say which nodes are conditionally independent given a single other node. Okay, like suppose we are saying that 3 and 5, suppose we are saying that 3 and 2 they are independent given any of the node. Any of the node can be like 4, it can be 1, whatever. Suppose is there any node that we can block so that 3 and 2 are independent? So is it possible, and if yes, then what is the node that we can block? So 3 and 2 are they independent? Can they be independent if we block only one node?
0 we can block, so
Right. So yeah, so here 3 is going to 2 via 0, and there are no other option, it has to go via 0. Okay, so if we block 0, then 3 and 2 becomes independent, so 3 and 2 is correct. What about 0 and 4? Can we block one node such that 0 and 4 are independent?
no.
Right, because 0 to 4 we can go via 2 as well as 5. So if we block 2, it can go to 4 via 5. If we block 5, it can go to 4 via 2. So this option is not correct. 0 to 4, they will not be independent if we just remove only one node. Okay. Then 2 to 5, 2 to 5 are they independent if we remove one node?
No.
No. Yes, because again here there are two parts, 0 and 4, via 0 and 4, and if we remove 0 it can go via 4, if we remove 4 it can go via 0. So again this option is also not correct. Then last option, 1 to 5, 1 to 5. I think it is straightforward, only there are only one node in between, and if we block this node, then it is possible that 1 and 5 are independent. So this option is true. Okay, so now we are done with these structures. Maybe we can come back to it later on. Now let's move to a numerical. So we have a spam filtering system, and especially consider like Gmail. Okay, a Gmail spam detection system, and like it is able to give correct answer. Like if the email is actually spam, then it is able to tell that yes, it is spam 95% of the time. But in if it is not a spam, in 10% of time it says that it is a spam. So this is called false positive, right? So it is considered that 0.5% mails are actually spam, and like 50% of the emails are spam, and 50% of the emails are like not spam. Okay, so suppose we have a new email, and what is the probability that it will be classified as spam? So we don't know what is the new email, is it spam or not spam, but given we don't know anything about this new email, and we have P of correctly predicting a spam is 90.95 and P of false positive is 0.10, and then what is the probability that it will be classified as spam? Okay, I'll give you some time if anybody wants to calculate the results. Okay, I'll quickly give you the variables right now, but not the answer. So basically, we are considering S means the model is predicting it as a spam, and M means it is actually a spam. So model predicting it spam given it is actually spam is 0.95. Model predicting spam given it is not really a spam, M prime is 0.10, and okay, so here consider it as a 0.01, not 0.5, 0.01. So the chances of it being actually spam is 0.01 because it's like 1 by 100. Okay, so if we go to the solution, we have to find this, right? P of spam, like the question is what is the probability that mail will be classified as spam, but we don't know if the mail is actually spam or not. So there are two scenarios: probability of predicting it's spam and probability that it is a spam, right? Then probability of predicting it's spam given it is not a spam, right? So these two are the options. So first P of S given in M is this one 0.95, and P of M is actually the probability that it is actually a spam is 0.01. So we take the multiplication. Then S given M bar, so that is 0.10 as from here, and P of M prime is not a spam, which is like 1 minus 0.01, so 0.9. Okay. So if we multiply this and add, the answer will come out to be 0.1085. So this is the answer. Okay, then next question. Okay, so we have a Bayesian network here, and P of F here is 0.01. Here P of C given F is 0.8, and P of C given not of F is 0.3. So we have to find P of C here. This one is given, this condition is given, and we have to find C. Okay, Lakshmi, can you tell me which question you are talking about? I think it is this question, right? So okay, maybe after solving this question, we will go to that question. Okay. Okay. So we have to find P of C, right? So this is the diagram. We have moved it a little bit for convenience. So you have to find P of C, and we have these things given. Okay. So P of C means what? There is a transition from F to C, right? So here P of C means P of C given F into P of F, yes, plus P of C given not F into P of not F, because C is coming from F only, right? This is like conditional network. So here C is coming from F, and there are two values for F. Okay, one can be like true and false. So P of F is 0.1 and P of not F is 0.9, right? And we have the transition here, right? So the P of C given given like F is that P of C given F into P of F plus P of C given not F into P of not F. So if we just take the values, P of C given F is 0.8 and P of F is 0.1, yes, plus P of C given not F is 0.3 and P of not F is 1 minus 0.1, right? So it is 0.9. So 0.8 into 0.1 is 0.08 and 0.3 into 0.9 is 0.27. So totally it is coming out to be 0.35. So I hope it is clear. Yes, it is 0.35. Okay, so then let me move on to the previous question and discuss this one. Okay. So A is independent of B when E is known. So that is the claim, right? So what we are saying is that okay. So let's consider this. Let's consider it in two part. Okay, D to B, this part, and A to D. Let's consider this one. DCB, is D independent of B given E? So are they independent, D and B? Okay, okay. Let's find out this one. Okay. Okay. There are two parts. Okay. So it is kind of a transitive relationship. You can think it like this way. So this is one part, and this is another part. Okay. Or also you can consider this as one part and this as another part. It doesn't matter. Suppose this is one part and this is another part. So A is dependent upon B, right? Because they are directly connected. So A is dependent upon B, and then after that, are D and B are independent. So given E, which like as per the rule, suppose here, okay, D and B are children of C, so C is the parent, and whatever we said this, in the directed graph is that C is not blocked, right? So we can reach from D to B, right? From D to B we can reach, right? So D to B are not independent, because like in this case we are considering C is not known, right? So D to B are not independent. This part is not independent, right? So basically what is happening is here is that we have to find out if A is independent of D and D is independent of B, right? But this part is not really independent. They are dependent. So basically what is happening is that A is dependent on D and B is dependent on D, right? So it is kind of forming a transitive relationship where A is dependent on B. So is it clear now? So basically in the first option we have shown that no, not the first option. In first option it is C is known. Basically if we consider it in two part, D and B are dependent because C is not known here, and because they are dependent, it is breaking the relationship that like A is independent of D and D is independent of B. Because they are dependent, they are, you cannot say transitively that they are like independent, because you know this is actually dependent, right? A is dependent on D and D is even dependent on A, and B is dependent on D. So this is dependent and this is also dependent. So dependent transitive relationship, we are seeing that A is dependent on B. Yeah, right. Is there any question or something? Okay. Yeah, Lakshmi, you can. Yeah, you are right. Like initially, I was speaking it differently. It is like D is dependent on A. or whatever, like let me go there. Yeah, D is dependent on E. Okay, so this is done. Yeah, it is little bit more complex than the previous one. So we have a network, we have rain and we have sprinkler, and then it is going to wet grass. So basically in a home we have a kind of say garden with grass, and it can be wet depending upon if there is a rain, there are chances that it is wet, and if there are sprinkler on in the garden, then also there are chances that it is wet. So we have to calculate that P of S, which is that, so suppose we know that the grass is wet, we also know there was a rain, okay, and we have to find out then P of sprinkler, the sprinkler is on, based on these probabilities. So can anyone tell how to approach this question? How to find P of S given W, R? Okay. So basically whatever I have written here, we have just cramped it here to for space. Okay. So P of S given P of S given W comma R is P of S given W and P of S given W into P of S given R. No, that is not the case. So here P of S given WR. So S given WR means that how to find out? We have to find out the joint probability of all three W, S, R, and then we have to find out the probability of W and R. Okay, right? So P of W, S, R, and we have to find out here P of W, S, R plus W, S not R, because like here we don't have S, right? So if we take marginalization over S, right, if we take all the values of S and sum them, that means S will get cancelled, right? So if we do this, the resultant will be P of W give W and R, right? So P of W SR divided by P of W SR plus P of W not SR, this is we have to find out. Okay, so that means how to find P of W SR? What is the probability of wet grass given SR, right? What are the probabilities, and what is the probability of rain, and what is the probability of sprinkler on? So these three we need to consider. So W given SR is given, W given SR should be given, yes, W given SR is 0.8. Okay, P of R, what is the probability of rain? P of R is 0.1. What is the probability of sprinkler is on 0.2, right? So it is 0.016. This is the numerator. Okay, then let's find out the denominator. P of W given S prime S bar then R. So we have to find out P of W given S prime R into P of R into P of S prime, right? So what is the probability there? P of R, P of W given S prime R. So this one is the condition. P of W given S prime and R. So it is 0.7. Okay. P of rain is 0.1. Okay. And P of not sprinkler. So sprinkler, P of sprinkler is 0.2. And P of not sprinkler is 1 minus 0.2, which is 0.8. So if we multiply this, it is coming out to be 0.056. Okay. So this one is 0.016, this one is 0.056, and if we just take the like equation, if we put this into an equation here, it will come out to be 0.2222, like it will up to infinity. Okay, so this is the answer. So the main point to observe here is that since we did not have any values for P of W given R, P of W and R, so but we had values for WSR, it was obtainable. That is why we took marginalization over S, because if you consider all the values of S, it is kind of like summation of S over we are taking the summation of all the possible values of S basically here. So that is why how we calculate. Okay. Okay, so this is another question. You have these options given, okay, and you have this graph, and we have to find out. So here I means intelligence, D means difficulty, G means grade, S means SAT score, and L means letter. So what is the probability that observing this one? Okay, and you have the tables here. So can anyone tell, okay, let's forget everything. What is the probability of P of I equal to 1? From this table, can you say P of I equal to 1? Yeah, so P of I equal to 1 is here, okay, and the option is 0.4, okay, and then P of D equal to 0, so that is 0.06, sorry, 0.6, okay. So up to this, I hope it is fine, okay. So this is how we have to find out, okay. Then how about, so basically what is happening is here is that difficulty, it is not connected, it is not a child of anyone. Intelligence, they are not a child of anyone, okay. So we are taking those values directly. So here 0.4, d equal to 0, d equal to 0 is 0.6, and I equal to 1 is 0.4, okay. So these two we are taking directly. Then grade is coming from two parents, one is difficulty, another one is intelligence. So this one is conditional, right? So we have to find P of G given, what are you trying to find out? D equal to 0 and I equal to 1. So what is the P of G equal to 0 given we have I equal to 1 and D equal to 0. So this is the table for that, I, D and G. So which one is the correct here? This equation, P of G equal to 2, given d equal to 0 and I equal to 1. So from this table, which one is correct? Which value should we take?
Point 0.08.
Yeah. So here I equal to 1, d equal to 0, and we need to find out like g equal to 2. So here 0.08 is the value that we need. Okay, fine. Then later grade. Okay, later grade is dependent upon what? Grade. Okay, so L equal to 0 given g equal to 2, because we want to find out g equal to 2 also, right? So here up to this we have considered the probability of g of 2 given this, and then here we are finding that p of later equal to 0 given g equal to 2. So where is the graph for that? Here, right? So g of 2 into L, like g of L0 given g2, g equal to 2. So here it is 0.4. Okay, and finally we have this left SAT score. So s equal to 1 given I equal to 1. So that is also we have to find out. S equal to 1 given I equal to 1 is here 0.8. So if we just multiply everything, okay, 0.6 for d equal to 0, 0.4 for I equal to 1, here it is 0.08, here it is 0.8, and here it is 0.4. If we multiply everything, it will come out to be 0.006144. So this is the correct answer. Okay. Okay. So anybody having any confusion till now?
Sir, can you explain the last question, that rain question?
Yeah,
That
sure. Yeah. So basically, what is happening here is that suppose you have a home and there are a garden there, and you one day you come home and see that the garden is wet, grass is wet, and you also know that it was there was a rain that day. Okay, so but the grass can be wet due to the rain also, it can be due to the sprinkler also, right? Both can happen. So even if there is only rain, then there are also some chances that grass is wet. Even though only sprinkler is on, then also there are some chances that grass is wet. And it can also happen that both is on. Okay, the sprinkler was also on and there was rain, and that can be also a reason for like the wet grass. So what we are trying to find out is that we already know that there was a rain and the grass is wet. So
sir, in this, what is the last probability? It is wet when there is no rain and no sprinkler.
hmm.
How then grass will be wet?
Okay, my you can consider it was like sprinkler was on from the previous day, like there was rain in the previous night.
Oh, okay, okay.
Yeah. So basically here we are given uh, wet. We already know that grass is wet, and we already know that there is a rain. So what is the probability that sprinkler was also on? Okay, so we have to basically calculate we know these two conditions, right? And we have to find out s equal to true given w equal to true and r equal to true, right? So we have to kind of find out p of w s r, what is the probability of s equal to true and w equal to true and r equal to true divided by this part, p of w equal to true, r equal to true. Okay, so up to this I hope it is clear.
So this formula, how it has come? That this only like PWSR divided by PWR.
So yeah, we are just breaking this part. So P of S given WR means what? It means that what is the chances of S happening given we have W and R already happening, right?
Okay.
So that means we can consider it as a what is the probability of all three happening given we already know these two already happened, right? So basically those two mean same thing. Here we are saying that what is the probability of S given WR already happened, and here we are saying that what is the probability of all three happening divided by what
Oh,
is, yeah,
okay, sir. I got.
yeah,
Okay,
yeah,
sir.
what is the
Base
probability,
base theorem.
yeah, yeah, right. So what is the
Okay, okay.
probability of this happening, and basically we have just S left here, so that is why like we are considering that. Okay, then after that we have this one uh, P of W is sir, and here we don't have any W comma R, P of W of R, W comma R given here, but we can find that from W is sir, right? Because you know we have W is R given and W is this also given. Okay, so basically in this case, since these values are not available, we are introducing another variable S, and because S is not part of this equation, we are summing over all the values of S. So basically what is happening is, what is the probability of S and what is the probability of S prime. So they are actually getting added. They are basically if we add P of S and P of S prime, it is 1, right? So that is why if we are marginalizing, we are taking marginalization over S. So all the values of S, here only there are two values. So basically W is R plus W is not R, because there are two values. If there are like maybe it is like S equal to 1, S equal to 2, S equal to 3, those kind of things are there, then we'll take like those three additions. That is, and that is the like that is how we do it. So that is if we calculate these values, W SR is W given SR, right? So it can be other way also, S given WR, R given WS, whatever. Okay, they are the same. So W given SR into P of R and P of S. So it is 0.016. Similarly, this one also, W given not S comma R equal to 0.056. Okay, and if we take the like put this into numerator, put this into denominator, and also here in the denominator, and if we calculate, then the answer is 0.2222.
Okay, sir. Okay, sir. Thank you.
Okay, so we have a graph, and I hope you already know what does Markov blanket mean. So we are considering the node 4 here, and like which of them are not in Markov blanket of 4?
5 and 7.
Right. So Markov blanket means like what are the immediate neighbors of a node. So here you can see 1, we can reach 4 to 1 directly, so this is under Markov blanket. Okay, 2 is also under Markov blanket because 4 to 2, it is like just the neighbor. 3 is also because it is just a neighbor of 4. 4 itself is the like the node, so it is obviously. And 5 it is not really a neighbor, right? 4 to 5 we have to reach via 2, so it is not under Markov blanket. So 5 is one of the correct answer. Then 4 to 6 it is directly reachable, so this is not under Markov blanket. Okay, and 4 to 7 they are not neighbors, so this is not under Markov blanket. And 8 is directly reachable, there is a direct path here, it is neighbor, so 8 is not a Markov blanket, not under Markov blanket. So only 5 and 7 are in Markov blanket of 4. Okay. Which of the following will have no effect on H given Markov blanket of H?
CEF.
Okay, let me wait a little bit for other answers. CEF. So anybody would like to explain why CEF? Okay. So basically this is just the same as the previous question. In Markov property we are considering that only previous only neighbors have any effect on each. So here if we go through one by one, okay, A is direct neighbor of H, so it is having effect. B is having effect. C is not having effect directly, so C is not C. In the Markov assumption, because C is not a direct neighbor of H, we are considering that C is not affecting H. Okay. So C is one of the correct answer. Then D is a direct neighbor of H, so this one is not really correct answer. E is a correct answer because E is not really direct neighbor of H. Okay, so C and E are correct so far. F is also correct because H to F we cannot reach directly, so this one is also correct. G we can reach directly. H also we can, H itself is the node we are considering, so it is under the Markov blanket. I is also a direct neighbor, so this is also under Markov blanket, and J also under Markov blanket. So only correct answers are C, E and F. Okay, yeah, C, E and F. Okay, so these are the questions we are supposed to discuss today. So this is the final question. Okay, so we have 7 variables and we have this graph here, and we have to find the joint probability distribution of the variables in this network. So there are 4 options. I am keeping the screen on this question. It is little bit complicated to read, but please try to read it and find out which one is correct. So everyone is answering option A. Okay, so let's try to find out. So at first we need a few things. D1, D2, D3, they are not patterns of anyone, sorry, they are not coming from any other node. Okay, so at first we'll take this one, P of D1, P of D2, P of D3. So till this it is correct. Again this one also it is correct, P of D1, D2, D3, P of D1, D2, D3. Okay, and here we don't have P of D2. Okay, so this option is eliminated. Okay, this option is eliminated. We have P of, now we have these three options left, P of A, B and C. Okay, then let's go here D1 to S1. So S1 is dependent only upon D1, right? So P of S1 given D1, it is correct. P of S1 given D1, it is correct. S1 given D1, it is also correct. Okay, we still have three options left. Then let's go to S2. So S2 is dependent upon D1 and D2. S2 given D1, D2, so this is correct. S2 given D1, D2, so this is correct. Okay, this is D1 given S1, D2. So no, this is not correct because this is not clear the case. So D1 is not really connected to D2 at all. So this one is incorrect. So we have A and B left right now. Okay, D1, D2. Okay, then let's consider S3. S3 is okay, D1 and D3 dependent upon. So D1, D3, D3. So this is fine. Still both are options. Then S4. Okay, S4 is dependent only on D3. So S4 given D3, it is correct. Here it is written only S4, so this is not really correct. Okay, so yeah, this is the only option which is correct. Okay, so this one is the correct option. So these are the all the questions that we were supposed to discuss through today. So thank you everyone for joining, and if you have any doubts regarding any of the questions I have discussed here, we can ask. Otherwise I'll end the session. Okay, like I'll go through all the questions one by one quickly. Let me know like if you have any doubts. So this one was a MCQ about Markov property. Okay, and this one was the rules of like this was for like unidirectional. Okay, bidirectional rule is very simple, that if you have any node known, then that is blocked, and then you have to find out if and edge. Okay, so this one was for unidirectional, and this was for undirected graph, similar type of questions. Then again similar, this one was which node do we need to know, so that at only one node we need to block, so that some of the nodes are independent. Okay, so the next question was spam and ham classification. So ham means not a spam. Okay, so basically we are given the probabilities, and we have to find that what is the probability that a given mail will be predicted as spam, and we don't know if the mail is actually spam. So we just considered the two situations, where it is spam and where it is not spam, and we have just added them. Okay, then we had a Bayesian network. We have given the probabilities here, P of F and P of the C given F, C given not F, and we have find out P of C. Okay, and yeah, then we have this range sprinkler weight class. So this one I have discussed just right now. Then we have the transition probabilities of this these values, and we have to find the joint probability of all these observations. So again, that you can deduce like what is dependent upon what and get it from this table. Then we have discussed about Markov blanket. So I hope everything is clear to all of you.
Sir, can you show the third question, sir?
Third question.
Answer.
So this one is first question. Okay. This one.
Previous one.
This one.
Yes, one.
Yeah.
Okay, sir.
So okay. So thank you everyone for joining.
Sir,
Yeah.
sir, can you go through that week 9 questions problem solving session? First question.
Yeah. Okay. First question.
No, not from here. I'm telling you from week 9.
Assignment.
Yes,
Oh,
assignment.
sorry, I cannot go to the assignment. This year assignment I cannot discuss.
Sir, actually, last assignment also, question number 5, they have given a wrong solution.
So yeah.
Yes, sir. Actually, through that only doubts are there. That's what we want to clear. But
Ma'am,
no one
actually,
is.
you told week 9, that is why sir told week 8, sir. Actually, she meant.
Okay, week 8. Okay.
Sorry. Week 8 only. Week 8, not week 9. Week 8. Please, sir, go through week 8.
Okay. So okay.
Wrongly, I said.
Yes. I think I saw some emails also regarding question 5.
Yeah, sir, question number 1. Week 8, question number 1. Then you can go
Okay,
from 5.
just go to the solution. Yeah, this one.
Yes, sir.
Okay.
How the answer is question A and D? I just want to know.
Okay. So
Because all the nodes are downward and A, B is the parent node, and in the option D, they are telling A and B are not independent given D. How it is not independent, sir? A and B?
A and B. Okay. Given D. Okay, so I think I had a similar question here also. Let me show. Okay, just wait a minute. A and D given E. Yeah, this one I guess. So here A is independent of C when E is not. Okay. Anyway, so okay, let's go there. Let's go to the here. A, B is independent of F given D. Okay, so in this case D is blocking, right? Okay, let's consider it this way: B to C, C to D. So B to C are interrelated, and but here suppose D is blocking. In that case, they are
But sir, parent nodes A and B both are the parent nodes, and parent nodes are always independent, na? They can't be dependent because in option D it is mentioned A and B are not independent. That means A and B are dependent, dependent and giving D. How it is dependent? That's only my
okay.
doubt.
So if you see the rules here, let me go to the rules. Yeah, in case of like unidirectional graph, this is the case, right? So there are two parents, y and x, and z is the child, right? So they are independent if z is not given. Okay, if z is given, then they are dependent. Okay, so
Okay. Then this is the case. Based upon this case, we have to identify A, B will be dependent or not. Based
yes,
upon that case only, we have to identify.
right.
Okay, sir. Got it.
Right.
Thank you, sir.
So like yeah, if in any of the question, like if you have any doubts also, like if you have
Question 5, sir. 5.
Question 5.
5.
Yeah, yeah, I actually saw emails for this question. Okay, so maybe the admin will check. So previous week also there was some mistake in the evaluation. I like emailed them and like they have rectified the errors. I think the error was re-evaluation, right? I got emails for that.
Yes, sir.
Yes. So if like if the answer is wrong, it will get it evaluated. Okay, don't worry.
Okay. Sir, normally all the other courses they will be replying, but here machine learning course no means reply from the faculties or maybe the people who are making the paper. It is not that good.
Yeah, kind of. It is kind of yeah. It is little bit slow, but like you will get some response actually. Like it is not that.
Because one more question I asked, that was I think week 6. In that I think all the options were shown correct. They gave the explanation, but only A, B, C they have given as the right answer. But explanation wise, all the 4 options were correct. So for that, no reply was given.
Okay.
Okay.
Okay. Anyway, like all these things will get considered actually. So if I hope they will. Okay, I'll then week 6 I got. I remember actually. So maybe I will ask them again. Okay, to reply.
So because here we are fighting for single numbers because number of questions are less. Normally,
Understood.
all the assignments we are getting 15 questions, so that the percentage of loss what we are having, that is less. Here we are losing a lot of percentage. If one answer is wrong, 12%, 12.5% is going,
Right. Right.
and somehow we have to reach. Means we are also. I think all are doing PhD, so
Oh,
all have to reach to means stipulated numbers like
right. Right.
60%.
Right. Hmm.
So it is difficult.
Right. So yeah, I'll mail them once again to like look into this. So
Okay, sir.
okay,
Thank you, sir.
can you just write the question number that you are asking?
So I think week last this assignment week 8. I think Harpriya also has given. I have also given. A lot of people have given the
Yeah, yeah,
representation,
yeah.
and I think week 6.
Yes, sir. Actually, there we also raised the questions. Until now, we didn't get the any feedback and any answer they are not giving. For me, also question one I asked repeatedly, but no one is going to be respond and no answer. Also, we got.
Yeah,
That's the issue only happening there.
yeah, yeah. So yeah, they are a little bit slow to respond. I'll again mail them. Okay. So
Because here also question number one, as you said, sir, based upon that case, that they should write answer and get rectified our question. As well as if you are having any doubt, also further we can ask now.
yeah,
They
yeah.
are also writing it.
Sorry, your voice is breaking.
Yeah, yes, sir. That's what I'm asking. Just I need the answer. Like that's what as Sar said also. For that only we are asking the question, so that we can be rectified now. Whatever our doubts and all, it will be rectified in our final exam also.
Right, right. So yeah, like yeah, the original answer sheet should contain the correct answers. But again, if there are some mistake, I will yeah tell them. But yeah, for now, can you give me the list of questions where you are having
Sir,
issues?
from my side, question number one, I like as you said, it is based upon one, but still I'm having the doubt.
Okay,
So question number one, can you please again
okay,
check with that?
okay. Week 9, question 1, right? Sorry,
We
week
get
8.
question number one.
Okay. So okay, let me do one
We
thing.
get question one.
Let me do one thing. I will email them and let's wait for the official response because they are the one who will give the final answer. Okay. So we get question 1. Anything else?
Sir, week 8 question 5. I think they have given. They have changed the question, but I think option they have taken wrong. So
Okay.
that they have to rectify.
Okay.
And week 6 question number 6 that I have
So
posted twice.
week 8, question 5 is
6.
change the question, but
So you can also go through. I think you have downloaded that PDF
yeah,
and that similar question last time you have shown in our assignment also.
yeah, okay,
Same. So can you go up? That.
yeah,
So this question.
yeah,
It
yeah.
is.
I saw your emails. Yeah, I got it. I
So
saw your email.
answer week 6 question number 6.
Okay, so what is the issue with that? Week 6, question 6?
Week 6, I guess all the answers are right. They have given A, B, and C only right. And the explanation what they have given, that is for all the options. So
Right, yeah,
option number D also should be
I
correct.
also saw that. So,
And incidentally, this question was asked, I think, last to last year. So there, all the options are right.
okay, so,
So in 2 years, I think after COVID, answer got wrong. I don't know what has happened.
yeah,
Sir, you can go to the last
yeah,
explanation. They
this is,
have given.
right, yeah, it's,
Sir,
mhm. Sorry, your voice is breaking.
answer is factory. That question also repeat week 8, question number 5. That answer is factory. That is also one of the NPTEL week is solved by IIT Madras only.
Right,
That question I also saw. That answer itself it is showing factory. So
yeah, like
I
they,
think that is correct. But Harris raising it is wrong. I don't know how it is wrong.
No,
yeah,
ma'am. Actually, if you solve, no, it will be option B, office. Factory is not correct because they have put a condition. It should not be having more. Like it should have only one floor. It should not be multi-story. So when we solve, I think
Okay, okay,
most of the people have given representation.
anyway,
Okay,
so,
so we can give them and let them respond. That is the
yeah,
only thing we can do from our sides.
Yeah, yeah, yes, yes.
yeah, yeah, they will respond, don't worry, but yeah, they are a little bit slow, I understand that. So, it is difficult for you. So, I'll again remind them, okay? So, okay, so week 6, question 6, and week 8, question 5, and week 1, question 1, okay?
Sir, week 8, question 1,
Yeah,
not
yeah,
1. Week 8, question 1, and
week 8,
Ma'am,
question,
that I think that is correct, madam.
week 8, question 1, right?
okay.
Yeah,
Yes. As per me, I think A, B, C is the correct answer as per that parent nodes because all the arrows are downward. So
okay,
that I'm
so,
thinking.
yeah, I will escalate it to them, and they will give an final answer, okay?
Okay, okay, sir. Thank you, sir.
So, thank you everyone, and
O-
bye.
Okay, sir. Thank you, sir.
Okay.